This video we're going to be talking about solving simple exponential equations. For instance, an exponential equation is where at least one of the sides is written where the variable is in the exponent. For example, if you have 5 to the x equals 25, or 3 to the x equals 27, that'd be considered an exponential equation. Now, the answer for these is that x equals 2 because we know that 5 squared is equal to 25 and 3 cubed is equal to 27. So these problems above are pretty straightforward because, again, we know our basic powers of 5 and our basic powers of 3. They're simple integers, but obviously they can become more complex. So if you look at solving the exponential equation, we're going to focus first with looking at those that have the same base. For instance, you have 4 to the x plus 2, so now you have a operation or operation or multiple in the exponent, and that's equal to 4 to the 10th. So these have the same base already. So in order for this equation to be true, the bases must be equal to each other, and that means that the exponents have to be equal to each other. So once you have bases which are the same, then you can just simply set the exponents equal to make it x plus 2 is equal to 10. So we set this left exponent equal to that right exponent because we already have the same base. And thus x will equal 8. As long as the bases are the same on both sides, no matter what they are, the exponents can be set equal to each other. So here's 3 more quick examples. If you had 9 to the x plus 2 equals 9 to the 10th, or 38.5 as your base on both sides, or even if you had 1/2 as your base on both sides. As long as it's the same on both sides, you can set the exponents equal to each other, and you would end up with the same equation in these particular examples, and x would equal 8. When you have equations where there are different bases, then that becomes a problem where you have at least one more step. So for example, let's stick with the base of 4 on the left, and you have 2 to the 2x plus 7. Well, now this is equal to 16. We still need the bases to be the same in order to be able to solve. That means that we must convert one of those bases, one side, so it has the same base as the other. We're always going to be converting the base which is larger, or the side which has a larger base, into the smaller one. So 16 can be rewritten as 4 squared, because we know that's a simple power of 4. Well, now we have turned it into a problem that has the same base like we had before, and you can just set those exponents equal to each other again, and you can go about solving where you would subtract 7 to get a -5, divide by 2 to get -2.5. So you must have the bases equal to each other in order to set the exponents equal to each other. So that's going to be your first step. Let's look at a slightly more complicated example. Now we have exponents on both sides. 5 to the 3x minus 7 is equal to 125 to the 2x plus 4. So both of those have an exponent, but they do not have the same base yet. We need to turn 125 into the value of 5 to some power. So 5 cubed is the same thing as 125, and now we see we have the base on the same base on each side. However, there's one more step which a lot of students make mistakes, and so this is a key step in all of this process, and that was to turn this into a slightly different equation, or look differently, where you have 5 to the 3 times 2x plus 4. What we're using here is our power property. And again, what that tells us is that if you have a power of a power, you get to multiply those things. So 5 to the 3rd to the 2x plus 4 tells us that you can multiply those. So that's really important because what you need to do now is do the distributive property with this 3 to multiply to both parts. And that's a very common spot where students make mistakes. So this would become 5 to the 3x minus 6 is equal to 5 to the 6x plus 12. Now we have it written where you have the bases where are the same. There's no power inside here. We've multiplied it through. We've done all that work to make it look similar to our other examples. And so you can just set those exponents equal to each other. 3x minus 6 equals 6x plus 12. You get your x's on one side and your 1's on the other. Finally, you finish by dividing by 3 to get x equals -6. To be able to solve exponential equations, they need to have the same base. If they already have the same base like the previous examples, it's pretty straightforward. You just set the exponents equal to each other to solve. If they don't have the same base, you need to convert the larger number into the smaller number with that power that creates that value as equivalent so that you can use your power property and then be able to solve.